Okay. There is special case for incompressible flow, for example, a compressor. Okay. In this case, during a steady flow process, we know that volume flow rates are not necessarily conserved, although the mass flow rate conserved. So previously, we have three types of conservation of mass, which is conservation of mass, conservation of energy, and conservation of momentum. But there is no conservation of volume flow rate. Okay, in this example, for example, a compressor, okay, we notice that the inlet m.1 is 2 kg per second, okay, and the v.1 is 1.4 meter cube per second. But after passing the process in air compressor, what happened is, you will notice that the mass flow rate remain the same, which is 2 kg per second, and the volume flow rate reduced to 0.8 per second. Why this happened is due to the effects of higher density air at the compressor. Okay, so means the volume flow rate into and out of the steady device may be different. So the volume flow rate change due to the higher density of air compressor at the compressor exit. Okay, so means the density of air increase at outlets. Okay, as we know that the formula, in order to calculate that, okay, we know that m dot in, okay, is equal to m dot out. So automatically we know that the formula m dot in is rho v1, rho 1 v1 and a1, it should be equal to rho 2 a v2 and a2. Okay, so how to prove it? We know that the density change is, for example, in m1, okay, in outlet 1, the inlet, sorry, for example, in the inlet. Okay, in the inlet, we know that rho 1 v1 a1 or is equal to rho 1 v dot 1, okay, is equal to 2 kg per second. Okay, 2 kg per second. Okay, so the density of rho 1 okay, so means the rho 1 should be equal to 2 kg per second divided by V1. What is V1? Is 1.4 meter cube per second. So here you will get the rho 1 is around 1.4 3. It's around 1.43 kg per meter cube. Okay, so we calculate for the rho 2. Rho 2 is equal to 2 kg second divided by our v.2 is 0.8 meter cube second. So we will get the rho 2 is 2.5 kg meter cube. Okay, from here it's proven that the density have changed from 1 to out. So means that the row 2 has higher density of row 1. So it's proof that the compressor had increased the higher density at the exit of the compressor. Okay, we go for the next example. Okay, example 1. Okay, a garden hose attached with a nozzle is used to fill a 10-gallon of bucket. Okay, so the inner diameter of the hose is 2 cm and it reduced to 0.8 at the nozzle, means the exit of that hose, the nozzle is reduced to 0.8 cm. So if it takes about 50 seconds to fill the bucket with water, so determine A, the volume and mass flow rates of water through the hose. Okay, so we know that here the question is, we have a bucket about 10 gallon. Okay, so 10 gallon. So this is about 10 gallon. Okay, so it takes about, so you have, it takes about 50 seconds to fill. Okay, T okay, so this is the nozzle. So the hose will be like, you have a hose here, then it reduce, then this is your jet flow. So here the D is 2 cm, and here D is about 0.8 cm. Okay, so this is happen at the nozzle area. Okay, the question number 1 is A. Okay, the question is so find the volume, flow rate and mass flow rate. Okay, so we know that the volume flow rate, okay, is volume divided by time. So means how long it will takes the volume in in the duration of time. So we know that the volume of a bucket is about 10 gallon. So the time is, delta T is, it will fill until 50 seconds. So we convert this one to liter per second. So you should times with 3.7 854 liter divided by 1 gallon. So you will get the answer of 0.757 liter per second. So this is your answer of volumes. Okay, so we also know that in order to calculate next is mass flow rate, is mass flow rate is equal to rho V dot. So our density is assumed to be 1 kg per liter. So we need to times with the volume flow rate is 0.757 liter per second. So you will get the answer of 0.757 kg per second. Okay. Okay, then for question number 2. For question number 2 is find the average velocity of the nozzle. Okay, we know that V dot is equal to velocity times area. In this case, the question is ask you to find the nozzle at the exit. So it should be at the nozzle exit. So V dot, okay, V dot is equal to 0.7 okay, is equal to 0.75 liter per second. Okay, so we need to find the area. So the area is area at the exit. Okay, so we know the area, the formula of area is pi r square. So here you should take pi. Your r is the exit, is this one. This one, exit. Okay, so you should take the R is 0.8 divided by 2 is 0.4. Okay, centimeter cube. So make sure you change everything in meter cube, so you will get 0.5027 times 10 to the power of negative 4 meter cube. So back to this equation, so we can get the velocity is equal to V dot divided by A. So okay, your V dot is 0.757 okay, liter per second. So divided by 0, okay, divided by your A. So at the end you will get the answer of 15.1 meter per second. Okay. Okay, we go for example number 2. Okay, for example number 2 is you have a tank. Okay. Okay, you have a tank which is the height of 4 feet. So we know that height of 4 feet. So means H naught automatically we know this one is 4 feet. Okay, so the diameter of the cylinder is 3 feet. Okay, so the next is the diameter of hose, or mean D-jet, is equal to 0.5 inch, and the V is equal to square root of 2 GH. Okay, so the question is determine how long it will take for the hose, determine how long it will take for the hose water in the tank to drop to feet bottom. So automatically we know that H2 is 2 feet. Okay, so what should we do is, first of all, based on the continuity equation or conservation of mass, we know that M in minus M dot out is equal to the integration of mcv by dt, dmcv dt. Okay, so M in is equal to 0 because there is no flow inlet going inside, so it's a tank. So the M out, automatically we know that M out is equal to rho VA, or is equal to rho, just now our rho V is 2 GH times A. Okay, which is A is a jet. Okay, so the outlet A, so this A, okay, the jet A. Okay, so from here we know we need to calculate the A jet. Okay, based on this formula we know that A jet is equal to pi d square divided d square jet divided by 4. Okay, so we also know that, okay, this one is done, the next is this one. Okay, the third one. Okay, we know that mass control volume is equal to rho V. V is a volume, means rho times density. So O is equal to rho V, volume is area of tank, times H, the height. Okay, so when we put okay, then the area of tank is equal to small t. Okay, area of tank is equal to pi d square tank divided by 4. Okay, so when we put all these things, this one, okay, this one, and this one inside of the main equation of this one, okay, so what you will get is negative, because of this one is, okay, m dot is 0, so means that 0, then there is a negative here, negative, so should be a negative here, negative, okay, negative. So we know that m dot out is rho, okay, square root of 2 g h a z, okay, is equal to d differentiation of mcv, which is this one, so rho a tank h over dt, okay, or it can become in term of when put the area and this area inside, so it become negative rho 2 g h by d squared over 4, this is for z, is equal to rho, okay, pi d squared tan over 4 dh over dt. Okay, so from here, okay, automatically we can cancel it, some of it. For example, rho and rho can be cancelled, okay, so you will have pi will be cancelled, 4 will be cancelled, so at the end what you will get is dt is equal to negative d square tan divided by d square z, okay, times dh divided by square root of 2gh. Okay, from this equation we know that the question said that for t1 t0, okay, your h is equal to h naught, okay, like this, t0 is h naught, okay, and t final t or t final is equal to h is equal to t final is equal to t, okay, or and h equal to h2, okay. So from here, okay, we can integrate. In order to get the t, we should integrate the dt. So what we can do is we integrate the t from t to 0, 0 to t, okay, dt is equal to negative dt square of 2 divided by d z square root of 2g. Okay, so integration so it should be dh integration of h naught to h2 of dh square root of h. So here you will get t is equal to h naught minus h2 divided by g over 2 times dt divided by dz square. Okay, as we know that h naught, we know that h naught is equal to 4 feet and h2 is equal to 2 feet. So we can put everything inside of this equation. So you will get t is equal to square root of 4 feet minus square root of 2 feet, okay, divided by square root of g is 32.2 divided by 2 feet per second times, we convert 3, okay, we know d, previously the d is 3 feet, but we need to change everything to inch, so it times 12 inch divided by 0.5 inch, 0.5 inch square. So this 0.5 inch is the diameter of dz. So the final answer you will get 757 seconds, or equal to 12.6 minutes. Okay, so this is your final answer.